everyone. Welcome back to Tech is Strong with Shobhit. I hope you are doing great in tech and fitness. Today, we are going to cover the topic which only 1% of the engineer knows that. If you already knows that, please watch out as well and tell me what's new you have learned today. And one more thing, guys, like I'm covering the syllabus which helped me to get Google, Microsoft, and Qualcomm. So please watch out other 10 episodes as well and subscribe to the channel such that you will not miss the other episodes of this syllabus. Today, we will open a program's brain, not theory. We will see exactly where code lives, where global lives, where malloc goes, where function call goes. This topic is literally the difference between guessing bugs and hunting bugs. Once you know where things live, you can predict failures before running the code. So after this, you are able to understand hard crashes, stack overflow, heap corruptions, global static, and embedded memory constraint bugs. Let's see the big picture. Please have a look on the diagram which having in the slide. Every process gets this layout. Code at bottom, stack at top. Heap grows upward, stack grows downward. If they collide, game is over. If you see the text section contains your code or instructions. Data contain initialized globals or static variables. BSS contains uninitialized global and static variables. Heap contains the memory which you allocated through malloc or new. And stack contains your calls, function calls, and local variables. So don't worry if you didn't understand that. We will look each part one by one in the following slides. Let's see what is text segment. Text is your actual compiled CPU instruction. It is usually read plus execute. So nobody can overwrite your code at runtime. That is also why bugs like buffer overflow try to jump into executable memory. And it also stores read-only constants, which is RO data. Let's see data segment. If a global or static has a value already assigned in code, it goes to data because its initial value must be stored somewhere inside the program image. Let's see the BSS segment. BSS is the smartest segment. Uninitialized globals do not need space in the executable file. Loader just allocate memory and zero it out efficiently. If you remember only one slide from this episode, remember this. This alone fixes 50% confusion in interviews and debugging. Like has an initial value, then it must go to data segment. No initial value, it will go to BSS. If it is a local variable, then it goes to stack. If it is coming through malloc or new, it will goes to heap. So we will see this stack and heap in following slides. What is stack? The stack is automatic memory, very fast, very predictable, but limited. That is why huge array inside functions are dangerous. They can crash instantly. What is heap? Heap is freedom with responsibilities. You can allocate any time, any size, but you must free correctly. Most production bug is heap misuse. Let's see the comparison between stack and heap. If a stack fails, you will crash fast. But if heap fails, you will crash randomly. That's why heap bugs are nightmares. Like for example, you are allocating some memory on heap, but you are not freeing that. And this happening again and again. So at one time, your program might crash because you are allocating the memory, but you are not deallocating. So memory got full. So no space for stack as well to execute uh, the other functions and all. Big interview trap. People think static inside a function is a stack because it is inside function. But no, it lives in data or BSS and keep value across calls. Scope and lifetime are different universes. Static variables may be hidden, but it is stay alive forever. So you can see the example where static int x, which is considered that to be inside a function. So its scope will be local, but its lifetime is the entire program. Now we understand everything. Let's have a look on example. So on slide, first line is like int g1 equals to 5. So it is a global variable plus value is initialized. So it should go to the data segment. Next is int g2. It is a global variable, but no value is assigned. So it will go to BSS segment. Let's go into the function like void f. So um, first line of the function is int a equals to 10. So it's a local variable. So it will go to the stack. Next is static int s. So it is like a static variable and it is uninitialized. So it should go to BSS segment. The last is the memory, which I'm allocated through malloc. So it must go to the heap. So that's how you can decode each variable, where it is going, and what is the lifetime of it. So you can see that the static int s, its lifetime is throughout, but scope is local. Let's have a look to the final summary. First is text, which contains instruction, which having a read and execute permission. You cannot write it, and also contains the constants. Next is data, which contains the initialized globals or static variables. Next is BSS segment, which contains uninitialized globals and static variables. And at the end, it will be zeroed. So that's why you can see that your global or static variable initialized with zero by default because of that. That's a property of BSS segment. Next is heap segment, which contains the dynamic allocations. And the last is stack, which contains function calls plus locals. If you understand this, you have already above most engineers in debugging clarity. So drop your answer in the comment and read out, like tell me that where it X's live and what is the lifetime of the X. I hope you understand the program's memory layout in depth. And trust me, guys, you are ahead of many engineers now. Keep doing hard work and stay strong in life and fitness. Thank you so much for watching.